In this video, we're going to continue our discussion of power series. Find the radius and the interval of convergence of the power series summation n equals 1 to infinity 2 to the power of n times 2x minus 4 to the power of n divided by n. We will start by applying the ratio test with the general term a sub n is equal to 2 to the power of n times 2x minus 4 to the power of n divided by n. So applying the ratio test, we have limit n approaches infinity, absolute value of a sub n plus 1 divided by a sub n. This is equal to absolute value, so limit n approaches infinity of absolute value of, now plug in n plus 1 for n, we're going to get 2 to the power of n plus 1 times 2x minus 4. So wherever you see an n, plug in n plus 1 divided by n plus 1 divided by a sub n term, which is 2 to the power of n, times 2x minus 4 to the power of n divided by n, absolute value. Now let's simplify this, so we get limit, rearrange it and simplify. Limit n approaches infinity, absolute value of 2x minus 4 to the power of n plus 1 divided by this term. We're dividing by this term, so it reciprocates. We flip the fraction. So divided by 2x minus 4 to the power of n times. Now we have 2 to the power of n plus 1 in the numerator, and in the denominator we get 2 to the power of n times n divided by n plus 1. Simplifying this further, we get limit n approaches infinity, absolute value of 2x minus 4. We have the same base, so we subtract off the exponents, times 2. Again, we have the same base, subtract off the exponents. We get 2 to the power of n plus 1 minus n. We get 2 to the power of 1 times n divided by n plus 1. We only put the absolute value on this term 2x minus 4 because that's the only thing that can potentially be negative. This part is always positive. All right, so what we have is absolute value of 2x minus 4 times the limit n approaches infinity of 2n divided by n plus 1. So we divide by the highest power in the denominator, divide by n, divide by n, divide by n, and we get absolute value of 2x minus 4. Limit n approaches infinity. 2 divided by n is 1, 1 plus 1 over n. So simplifying this, 1 over n approaches 0 as n approaches infinity. We're going to get 2 times absolute value of 2x minus 4. So by the ratio test, this power series converges, converges absolutely if 2 times absolute value of 2x minus 4 is less than 1. We need to solve this inequality for x. Divide by 2 both sides. We get absolute value of 2x minus 4 is less than 1/2. Rewrite this without the absolute value. We get 2x minus 4 is less than 1/2, larger than negative 1/2. Add 4 to every term, and we get 2x is less than 1/2 plus 4, and larger than negative 1/2 minus 4. Simplify this, and we get 2x is less than 4 plus 1/2, that's just 9 over 2, and minus 1/2 minus 4, that's going to give us minus 1/2 plus 4. So 4 minus 1/2 is 3.5, that's 7 over 2. Now divide every term by 2 and solve for x, solve the inequality for x. We get x less than 9/4, larger than 7 over 4. This is the interval of convergence. Interval of convergence. And the power series diverges if 2 times 2x minus 4 is larger than 1 That means absolute value of 2x minus 4 larger than 1/2. And if we solve this inequality for x, we'll obtain x larger than 9/4 or x less than 7/4. For these values of x, the power series diverges. All right, let's find the radius of convergence. First, let's find the center of this power series. And to do that, we're going to let 2x minus 4 to the power of n is equal to 0. Take the nth root of both sides. We get nth root of 2x minus 4 to the power of n is equal to nth root of 0. So we get 2x minus 4 equal to 0. And we get 2x is equal to 4. Add 4 to both sides and solve for x. We get x is equal to 2. This is the center of the power series. So how do we find the radius of convergence? To find the radius, 9/4, take the right endpoint. The distance from the endpoint to the center gives you the radius. 9/4 minus 2. And simplify, we get 1/4. Or equivalently, we can say the distance from the center to the left endpoint, which would be 2 minus 7/4. And we again get 1/4. 1/4 is a radius of convergence. All right, so the radius of convergence is a distance from the endpoint to the center of the power series. So here we have the radius is 1/4, 9/4 minus 2, or 2 minus 7/4. The radius of convergence is 1/4. The center of the power series is 2, and the interval of convergence is between 7/4 and 9/4. So if you want to find the center, just look at the power series and make this part equal to 0. And ask yourself, what is the value of x that makes this term 0? So set 2x minus 4 to the power of n equal to 0. That gives us a center. Then we subtracted the distance from the endpoint to the center, and we get the radius of convergence. But we still have to find out what happens at the endpoints. Because recall that the ratio test doesn't tell us anything about the convergence of the power series at the endpoint. So those have to be plugged in separately into the power series, and we have to evaluate the power series to determine whether the power series converges or diverges at those endpoints. So plug endpoints, x equals 7/4, which is a left endpoint, and a right endpoint, which is x is equal to 9/4, into the power series. Plugging the left endpoint, x equals 7/4, into the power series, summation n equals 1 to infinity, 2 to the power of n times 2x minus 4 to the power of n divided by n. We obtain summation n equals 1 to infinity, 2 to the power of n, 2 times 7/4, so 2 times 7/4, minus 4 to the power of n, divided by n. And if we simplify this, we're going to get summation n equals 1 to infinity, 2 to the power of n. Here we have 2 times 7/4, that's 7/2 minus 4, that's 3.5 minus 4, that gives us negative 1/2. So just doing a bit of algebra, we get negative 1/2 to the power of n divided by n. This is equal to summation n equals 1 to infinity, 2 to the power of n times negative 1 to the power of n divided by 2 to the power of n times n. Then we cancel these, 2 to the n cancels out, and we get summation n equals 1 to infinity minus 1 to the power of n divided by n. Now, what can we say about this series? Does this converge or does it diverge? Clearly, this is convergent by the alternating series test. So converges by, let's abbreviate, by the alternating series test. Let's prove that. The general term a sub n is equal to 1 over n, which is decreasing. It's clearly decreasing because the denominator is n, which increases as n goes to infinity. So we have 1, which is a constant, divided by a large number. The ratio is decreasing. So 1 over n is decreasing. And also the limit as n approaches infinity of a sub n is equal to limit n approaches infinity of 1 over n is equal to 0. And these are the two conditions for the alternating series test. So for that reason, we know that summation -1 to the power of n divided by n equals 1 to infinity, converges by the alternating series test because it satisfies the conditions of the test, namely that every term is decreasing, 1 over n is a decrease, the terms are decreasing as n increases, and the limit of the nth term is equal to 0. Converges by the alternating series test. Now let's plug the right endpoint. Let's plug x equals 9/4 into the power series, into summation n equals 1 to infinity, 2 to the power of n times 2x minus 4 to the power of n divided by n, and we're going to get summation n equals 1 to infinity, 2 to the power of n. We have 2 times 9/4, which is 9 over 2 minus 4 to the power of n divided by n. If we simplify this, we're going to get summation n equals 1 to infinity, 2 to the power of n times 9 over 2 is 4.5 minus 4 is a half, so we get 1/2 to the power of n divided by n. Simplifying this, we get summation n equals 1 to infinity, 2 to the power of n divided by 2 to the power of n times n. 2 to the power of n cancels out, and we get summation n equals 1 to infinity, 1 over n, which is a divergent p-series. Divergent p-series with p is equal to 1, or you can say it's a divergent harmonic series. Divergent harmonic series. So that means we should include the left endpoint x equals 7 over 4 for the interval of convergence, and we should exclude the right endpoint. Exclude the right endpoint, which is x equals 9/4. Because when we plugged in the left endpoint, x equals 7 over 4, inside the power series, we got a convergent alternating series. For that reason, we include the left endpoint. When we plugged in the right endpoint, x equals 9/4, into the power series, we got the divergent harmonic series, or the divergent p-series with p equals 1. That means we should include the left endpoint, but exclude the right endpoint. So the interval of convergence for the power series, summation, n equals 1 to infinity, 2 to the power of n, times 2x minus 4 to the power of n divided by n, is x between 7 over 4 and less than 9/4, or include the left endpoint, so we put a square bracket, 7 over 4, comma 9/4, and we put the open bracket on 9/4, because we don't include 9/4 and we include 7 over 4. So the interval of convergence is this. That means for any x value in this interval, between 7 over 4 and 9 over 4, the power series converges. That means the power series has a finite sum for all of these x values. But when x is larger than 9 over 4, if you were to plug in a value of x, let's say x equals 5, into this power series, then the sum of the power series would go to infinity. The power series would diverge. Similarly, if you were to plug in x less than 7 over 4, less than the left endpoint, so for example, if you were to put in x equals, say, 1 into this power series, then the power series would diverge. It would have an infinite sum. All right, so that's the general idea of the interval of convergence. All right, thanks.